What's poppin', dogs? Mr. Allen here with a video on the 4 most important types of factoring that you're going to get in Algebra 1 and use in basically every single math class beyond. So for the first one here, we're working with greatest common factor. Well, what does that mean? That means I'm going to try to divide out a common factor from each of my terms. So I like to start with my coefficients, my numbers. I got 5, I've got 10. What can I divide both those by? 5. So I can take a 5 out. Then I'm going to start looking at my variables. I've got x to the 4th. And x to the 4th is essentially x times x times x times x. And x to the 1st is just 1x. So I can take out 1x, leaving behind 3 of them for this term. We'll get to that in a sec. So I'm going to take out an x. And then the same thing for my y's. I've got y squared, or y times y. I've got y cubed, or y times y times y. So I can take out 2 y's, or a y squared, and now I can get to what's left over on the inside. Okay? So I took out my 5, so it's just a 1 left over. I took out the x, and I took out the y squared. So do I have anything left there? Yes. I got to put a placeholder of a 1 there. Anytime I remove an entire term, essentially, right? The greatest common factor is that term. I'm going to put 1 in its place. That way, if I multiply back in, I get the original problem. Now, for this guy, I divided 10 by 5, leaving me with 2. I took out 1 of my x's, leaving me with 3 of them. And I took out 2 of my y's, the y squared, leaving me with just a y, and now this thing is factored. Excellent. Wonderful. All right. Now, GCF can actually be used in any of the other types of factoring problems that you might encounter, so always keep that in mind as you're factoring, because it can actually make your life a little bit easier. If you got a lead coefficient, sometimes you can actually factor that out and not have to deal with the more difficult style of factoring of lead coefficient. All right, so next one here. This is really the most common factoring that you're going to see. A lot of people call it AM method, meaning I'm going to add to this guy while multiplying to that guy. Some call it just a guess and check or reverse FOIL. A lot of different names for that one. But in any event, I want to figure out two numbers that multiply to negative 24 while simultaneously adding to negative 5. So you might already know them, but if not, it's okay. Let's write out all of our factors of 24. That can often help. So I start with, like, say, 1 and 24. Well, if one of those is negative and one's positive, because it's got to multiply to a negative number, they're not going to add the negative 5. So it's not that. I've also got 2 and 12. It's not that. Let's see here. Do we have 3 and 8? Ooh. Difference of those is 5. So that's going to be our winner. But just to finish this off, we got 4 and 6 as well. Okay? So those are all my factors. And depending on what this middle term is, this is going to tell me which one I'm going to pick. So since we're going with a negative 24, one of these has to be negative, I start thinking what numbers have a difference of 5, and that'd be 3 and 8. So my factors will look like this. X will have a 3, X, and we'll have an 8. Now, which one's going to be negative? Which one's going to be positive? Well, I want it to add to negative 5, so it's going to be negative 8 and positive 3. Had that been a positive 5, this would be negative, and that would be positive. That is really the only change up there, okay? Now, remember how I said GCF can really come into play anywhere? It can. So let me give you guys like a what if. I always like these kind of scenarios in my math classes. I'm like, wait, what if this? What if that? Like those were things that I always thought of. So let me rewrite this as, let's say our first problem is 2x squared minus 10x minus 48. Well, what can you do in this scenario? Everything is divisible by 2. So I could take out a 2, and now I'm left with x squared minus 5x minus 24, and we get the same exact problem we had up here, but now my factored form has that 2 out front. We have x plus 3 and x minus 8. So if you have a greatest common factor that you can take out, do that right off the bat, and then you just have simple AM method or reverse FOIL, whatever you want to call it, right? So always be on the lookout for GCFs. It's not in every problem, but it can come up in any of these types of scenarios. All right. Next one here, we got difference of 2 squares, and I did throw a lead coefficient here to make it a little bit more challenging, and unfortunately, 81 is not divisible by 4, so we're just going to roll with it, okay? Now, you want to be able to recognize difference of 2 squares to make your life a little bit easier when factoring. This is a common style of factoring that comes up, and you could go through it in kind of a rough way like this particular problem right here that we're saving for last, or if you recognize that 4 is a perfect square, x squared is a perfect square, and 81 is a perfect square, and you can square root all of those, 2x and 9, 2x and 9, then all I'm going to have is one of them being positive, one of them being negative. That's it. A nice little mathematical pattern that you're going to see with these difference of 2 squares. Let me show you guys how this works. 2x times 2x is 4x squared. 9 times negative 9 is negative 81. Where's my middle term? Well, this is going to give you positive 18x. This is going to give you negative 18x. They cancel each other out. That is it. All right, last one here, dogs. We got the lead coefficient. This is always the most challenging style of factoring that students encounter. It takes a bit of practice. When we have prime numbers, 3 and 5, for the lead coefficient and the constant at the end, I prefer to use guess and check. Once I start getting into some even numbers, larger ones with a lot of factors, then I often do like factor by grouping. I will link that in another video with plenty of practice for lead coefficient up in the top right there, I believe. Okay, so for guess and check, here's what I do. I set up 2 sets of parentheses. I got 3x here, and I got x right here. How did I know that just right off the bat? Well, the only way to get 3x squared is 3x times x. Or x times 3x. There's no other way. So I'm just going to place those guys right there, okay? Then I got to think about my factors with 5. I've got 1 and 5. I've got 5 and 1. Now I'm going to show you guys the wrong way first, how to check it, and then go back and guess again, okay? So let's just say I'm going to throw 5 here, and I'll throw 1 here. The other option is switching them to 1 and 5. Well, if I were to multiply 3x times 1, I'd get 3x. Here I'd get 5x, 3x and 5x. If one of those is negative, because I have a negative 5, will they add to 14? No. So this isn't going to be the correct way, okay? But let's go ahead and try another one. We're going to still start with the 3x, and we're going to have the x. But now let's switch the 1 and the 5. So I got 1, I've got 5. Now, this is 15x, this is 1x. If one of those is negative, would it add to positive 14x? Yes. Well, what do I want to be positive? I want the 15x to be positive, which means my 5 will be positive, my 1 will be negative, and now I have 3x squared. I have negative 5 when multiplied. 15x, negative 1x adds to 14x. We guessed, we checked, we guessed, and we checked again and got our final answer there. That is it. Everything in factored form. That is wonderful. If you guys can master these 4 types of factoring, you're all set as far as factoring is concerned for most of your math classes. When you get to Algebra 2, you'll learn a little bit more about higher degree polynomials and learn about factor by grouping. But for now, mostly focus just on what you should know through Algebra 1 and into geometry and into Algebra 2 before you learn a couple more styles of factoring. Hope that helps you guys. If you have any questions, pop them in the comments or requests for videos, pop them in the comments. Otherwise, thanks for watching and stay dope.